Okay, if we look at section 4.3, we're talking about the binomial probability distribution. Within this type of distribution, you're only going to have two outcomes since it's a binomial distribution. And it's either going to be a success or a failure. And usually the person who's conducting the experiment or getting the data, they'll say a success to us would be this, and a failure to us would be that. Okay? But in order for the distribution to be a binomial one, it has got to pass all four of these rules right here. If it misses one of them, then we can't say that it's a binomial distribution anymore. So, number one must have a fixed number of trials. The trials have got to stop at some point. Within those trials, all the trials must be independent from each other, which means the outcome of one trial will not affect all the other trials. And within each trial, you only have two outcomes, the success or failure. And the probability of success remains the same in all the trials. It doesn't fluctuate from one trial to another. Okay, so N for us is going to be the number of trials. P will be the probability of success. Q will be the probability of failure. And X is the number of successes that occur within independent trials of the experiment. Or it will go between 0 and N, or your number of trials. So since we only have two probabilities, we have probability of success and the probability of failure. If that's the only probabilities, and I add these two things, so what I'm doing is I'm adding up all my probabilities, well, that's got to be equal to 1, because we know that the sum of all the probabilities are equal to 1. Now, if I have P and I'm looking for Q, if I subtract P from both sides, that'll give me Q is equal to 1 minus P. So that's why you see a Q here or 1 minus P. This is where it's coming from. Okay. Now the shorthand way to write that this is a binomial distribution is this right here. The little X with the squiggly line really just means the distribution is, okay, B represents binomial, and we have two parameters that are used to describe a binomial distribution. N, which is your number of trials, and P, which is your probability of success. Okay, so we could have something like, we looked at 500 trials, and the probability of success would be 0.3, or that's saying about a 30% chance of success. Okay. Now I want to also point out that your binomial distribution is always a discrete random variable. Now this will be more important when we get to 5.1, but your binomial is always a discrete random variable. Now if you are in a binomial distribution, the formulas for your mean, your variance, and your standard deviation have changed. The mean for a binomial distribution is N times P, variance is N times P times Q, and standard deviation is the square root of N times P times Q, which is basically the same thing as variance. You just put a square root over it. Because if you're going from variance to standard deviation, what you would do is square root. And if you're going from standard deviation to variance, what you would do is square. Okay? So say that 25% of all U.S. households are wireless-only households. In a simple random sample of 300 households, determine the mean and the standard deviation. Okay, so we'll go ahead and assume for now that this is binomial, which it is, but I'll show you later how to figure that out. So the mean for a binomial distribution is just N times P, and the standard deviation for a binomial distribution is the square root of N times P times Q. Okay, now a success in this situation is getting a wireless-only household. the probability of that happening is 25%. Okay, so P would be 0.25. Because remember, P is the probability of success. So probability only goes between 0 and 1. So that we need to get it out of the percentage. Okay, we're looking at 300 households. And Q is going to be 1 minus P, or 1 minus 0.25, or same thing as 0.75. Okay, so that means that our mean will be 300 times 0.25, which would give us 75. And our standard deviation will be 300 times 0.25 times 0.75, or that will give us 7.5 for our standard deviation. Okay. Now this is talking about going from a binomial distribution to a normal distribution. So basically, if your number of trials keeps increasing, so your number of trials keep increasing, it keeps getting bigger and bigger and bigger, then eventually your binomial distribution will go to a normal distribution. But to check when that actually happens, you have to use this right here. N times P has to be greater than 5, and N times Q has to be greater than 5. If these two conditions are met, then you can say that your binomial distribution is now really a normal distribution. Okay. So 25% of all U.S. households are wireless-only households. In a simple random sample of 300 households, 92 were wireless-only. Is this result unusual? And when we were talking about if something was unusual or usual, we were in a normal distribution. And we were talking about the empirical rule when we went over this. We said that the mean goes in the middle within one standard deviation, that is 68%. Within two standard deviation, that is 95%. And then within 3 standard deviations, that is 99.7%. And we said that if we were within 2 standard deviations, everything inside here was usual. But if we went outside of 2 standard deviations, that would be an unusual result. Okay, but we were in a normal distribution when we were talking about that. So first thing that we need to do is to check, is N times P greater than 5? Okay, so our N is 300. Probability of success is getting a wireless-only household, which is 25%, so 0.2. 75, okay, that one is greater than 5. That one checks out. And then N times P, so 300 times 0.75, because remember these two have to equal 1. 225, which is also greater than 5. So since both of those check out, that means that our binomial distribution is actually a normal distribution. Okay, well then that means, let me get rid of all this stuff over here. So that means I have a normal distribution. Okay, and we need to find the mean, which we actually found that back in this problem right here. This is all the same information as this over here. So our mean is 75. Okay, and then we need within at least 2, I'm going to go out to 3 standard deviations. So I'm going to take 75 and keep adding your standard deviation to get to the next number. Okay, so 75 plus 7.5, that'll give me 82.5. And then you'll have 90. So 82.5 plus 7.5 is 90. And then add it one more time. So 97.5. Now we were concerned if 92, if that result was unusual. So 92 is about right here. So there's 92. Okay, so this is within 1 standard deviation. This is within 2. Okay, so within 2 is about right here. Everything between these numbers is usual. Anything outside of it would be unusual. So since 92 is outside of 2 standard deviations, then yes, it is an unusual result. Okay, so then let's go through how do we check and see that what we're looking at is actually a binomial distribution. Well, it's got to fit all 4 of those rules. Must have a fixed number of trials, trials must be independent, only 2 outcomes, and P remains the same in all the trials. Okay, so an experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free throws, and the number of free throws made is recorded. Okay, so 1, is there a fixed number of trials? Well, yes, we're only just shooting 3 free throws, so N is 3. Okay. 2, are the trials, or shooting a free throw, are they independent from each other? Well, yeah, if I'm going to shoot and say I missed that basket. So because I missed that basket, that really doesn't affect my second shot. Okay, so those 2 things are independent from each other. So 2's fine. Number 3, are do you have 2 outcomes? Well, when I go to shoot the basketball, I only have 2 options. Either I'm going to make it or I'm going to miss it. So there's only 2 options. And then the probability of success, they say, is 80%. So that person makes 80% of the free throws. So P would be 0.8. And it doesn't say that it changes or fluctuates. It just says it is 80%. So P remains the same. So since all 4 of those rules check out, this one is a binomial distribution. Okay. So if we go ahead and find Q, that'd be 1 minus 0.8 or 0.2. And if we're going to find all the values for X, basically saying if you're going to shoot 3 times, how many times could you make it? Well, you could miss all of them. You could make only 1 of them, or 2 of them, or 3 of them. Or another way to write that is X between 0 and 3, just like they have it right here. X is between 0 and N. Okay, N is your number of trials. Our N was 3. Okay, so it only goes up to 3. So it's basically saying, if I'm going to shoot 3 times, can I make it 4 times? Well, no, because you're only shooting 3 times. So the max number is however many number of trials you're looking at, or 3 in this case.